Okay, welcome. We got another project for you today. This one we're going to be using this little sound sensor right here. It's going to be pretty easy to work with. We got 4 little pins to worry with, and they're all pretty clearly marked, at least on this one. They do come in quite a variety. Some have 3. So let's go ahead and jump into this and see how it works. I'm going to swap screens here. That looks pretty good. Let's make this a little bigger. Alright, actually starting off, let me put in here what you would already see. And you would also have that. So now you'll see what I see. Okay, so here's our sound sensor. At the bottom here it's labeled AO, G, plus, and DO. The G is ground, the plus is, we're going to hook up 5 volts to that. The DO is digital out, and the AO is analog out. We're going to take a look at both so we can compare them. And let's go ahead and press these into the breadboard here. We have to do a little bit of calibrating on this sensor, so we're going to do that first. Let's make our circuit. I'm going to use the black wire for my ground. Over here on my Arduino I have some choices. I've got a couple grounds over here and one right over there. It's G and D. I'm going to use this one. Then I'm going to use the red wire for my 5 volts. And this one, I've got 5 volts right here. I got 3.3 and 5 volts. So let's put that in there. Okay, I'm going to take my glasses off. I'm nearsighted, so some of these parts are really tiny. What we have to do next is we have to calibrate this. You'll notice we have 2 lights on, 2 LEDs on, and we're going to need a flathead screwdriver. And it barely fits. So let's go ahead and do some calibrating. What we want to do is there's a screw head right here. We're going to turn it until that LED just barely goes out. So if I go clockwise, I won't make any progress on this. I have to go counterclockwise. So I'm going to slowly go counterclockwise until it finally goes out like that. And yours might take a bunch of turns. I've used these before and it took 30-40 turns to get it to finally go out. And so the light on, light out, that looks perfect. If you look at it and snap your fingers, the LED just below where that screw head is will flicker. That lets me know that I've got a good calibration. It's a little bit hard to see on the camera probably. Alright, so that looks pretty good. Let's go ahead and do the next step, which is actually before we do the LED, and what we're going to do is take some sound and we're going to convert it into something, make it do something interesting by light up this LED. Before we do that, let's take a look at what we're picking up with this sound sensor. So we're going to do some programming, and to see things we need to turn the serial monitor on, and I spelled serial wrong. Need an A there. Notice when I put capital in there, the colors change. This lets me know that the computer recognizes it. When I go back to the S, it's back to black and doesn't know what it is, and it'll give me an error. But right now, we're going to, typing and thinking at the same time. I've set it up so that we're going to use 9600. This is the baud rate. This is how many bits per second. You can change this. This is kind of slow, but it's kind of the default setting. This will allow us to communicate with the serial monitor built into the IDE, and that is accessed through this little magnifying glass over here. It says serial monitor next to it, and we'll open that up and you'll see how that works. So that's that part. So we're going to open up the serial monitor, and the serial just means we're going to be setting them in an order, 1 bit at a time. Into the void loop. Actually, before we do the void loop, we're going to be collecting this information from the sensor, and we've got to store it somewhere. We're going to store it in a variable. So we have to declare a variable. We have to let the program know what type of variable this is. We have lots to choose from. We're going to use int, which stands for integer, and we're going to give it a name. This is the variable name. Let's call it sound sensor. We're using camel case here. The better is probably something like that or like that, but it's faster for my fingers to do that. So we're going to go with this style of variable creation. This is my bucket. This is where I'm going to be putting the information I get. And this is letting the computer know that this word you don't recognize, don't worry about it, it's just going to be an integer. It's going to be a number, a 1 or 2 or 3 and so on. Now we want to look at it. So we're going to use this bucket to collect data from our sound sensor, and to do that we're going to use analog read, and we're going to actually, getting ahead of myself, we're going to need this pin. Pull these glasses back off here. We're going to use this AO pin, analog output, use this yellow wire here, and we're going to use the pins on this side, the analog pins. I'm going to use A5 for my programming. So it's going to collect things, going to send it through this wire and into the Arduino through A5. So we're going to pick that up, catch it, and put it into the sound sensor variable that I just created. So we're going to do A5. I want you to read that and store it in here, and then we've got to look at it. So we're going to serial print. Whoop. I said whoop because it didn't change colors, and obviously there was a spelling error. So everything's typing in and changing colors for me, so I know it's happy. And we're going to do sound sensor. And we're just going to read it. And for now, I think that should be enough. So let's go ahead and upload this, send our code into the Arduino. I'm already plugged in here. Can't tell very well, but the lights are on. I've got my USB plugged into the computer, and I got to go up to Tools and make sure I've got the right port. Sometimes they auto-select. Try to avoid COM1. Use the select the largest COM that they have. This is 33, and it's already pre-selected. And usually the board is already defaulted to Arduino Uno. These are Arduino Unos, but they're all different kinds of boards. And here's some variety of types of boards here. I've got MKR zeros in the class and a few others, but mainly we're just going to use the Unos, so we're good to go. We're going to hit this button right here to send it. It'll compile it, it'll take a look at the code, find any errors, then it'll translate into zeros and ones, sending it to the Arduino. Down here we can see its progress, and right by my right ear, my little bar going across, and still uploading. Done. Now to view this, there's two ways we're going to view it. We're going to click here and take a peek and look at the numbers we have coming at us. We're being collected into that sound sensor variable, and I can say stuff to it and snap my fingers, whatever, and it doesn't look like much is happening. So we're going to look at it in a different way. We're going to go to Tools, we're going to go to Serial Plotter, and this opens up. And now I'm going to say stuff to it, snap my fingers, and we're going to say stuff to it again. So this is the information it's receiving. Notice along the y-axis here, it's only fluctuating from about 516 up to 28. So it wasn't changing much. We couldn't tell that very well on the serial plotter. This is the serial plotter. The serial monitor, we couldn't see it very well, but when we look at it like this, we can see that yes, it is picking up quite a bit. Now, as we've seen, analog signals are kind of a pain to deal with, so what we're going to do is just take a look at the digital output. That's probably plenty for us in getting this little project going. I'm going to pause right over here. Over here we have the baud rate. We had to make sure it was 9600. It matches what we see right here. If I switch it, besides crashing, you'll notice that most of the numbers are larger, so we can go a lot faster. Get this thing going again. So that looks pretty cool. Stop talking for a minute. We can go flat line again. Okay, so we're going to close that. We're going to take our analog wire, we're going to move it to the digital side. Just like that. We'll tilt it so you can see it a little better. Notice my LED on my sensor is still out, but it is flickering when I get close enough to it or snap. Then we're going to change our code around a little bit. Instead of analog read, we're going to digital read. And since we're going to do a digital read, we're going to change from an analog pin to a digital pin. We're going to go across, and let's select 2. I'm going to use 2. If you use a different pin, you're going to have to make sure you make that adjustment in your code. So we're going to read from pin 2, and we're going to add another line right up here. This will help make our LED a little bit brighter. We're going to do a pin mode. We're going to tell the Arduino that pin 2, or any of these pins, we could actually be sending information into the pin, or we can send it out of the pin. Right now information is going into the pin. So I want to tell it that. Whoop. Input. We're going to be sending, actually we don't have the LED set up. Technically the default setting is input. So I'm jumped ahead of myself again. I'm going to clear this out. I'm going to comment this out. We're going to come back to this. I really don't need to input tell pin 2, which is from the sensor, that's an input, because they're all defaulted to inputs. I have to set up and say be an output and tell it through a pin mode line on my code. So we'll pause on that. I'm getting ahead of myself again here. That's okay though. So I've got the digital pin set up. It's pin 2. We're going to collect it again. We're going to take a look at it. So we haven't changed anything here other than how I'm looking at the information. We went from analog to digital, and we're going to ignore this line just for a minute. So let's go ahead and upload this. Just by typing in here hasn't sent anything to my Arduino, so we're going to click on that. Wait a moment while it looks at it and sends it. So now it's done uploading. So that looks pretty good. Let's go ahead and, you can't see where I'm headed, let's shrink it down a little bit. I'm going to click on this serial monitor. So we'll click on that, and I got a bunch of zeros here. Let's go ahead and try to snap my fingers right next to it here. I can't tell anything's happening. We just got zeros. Remember, for digital we're going to get zeros and ones. I'm just getting zeros. So let's take a look at it this other way using the plotter. We did this exact same thing for the analog, and we're going to get like looking through a microscope, we can see what's going on a little easier. So let this thing start up, and then I'm going to click, right, snap my fingers. So when I snap my fingers, nothing happened on that one. Let's see if I can snap or whistle and stop this at the same time. Okay. So I captured it just for a moment here, and notice it's every time I make a sound, it stops at the same exact height. And that exact same height is a 1. So we're either at a 0 or at a 1. On the other one that I demonstrated, I should have done a screenshot or something, you notice that it was jiggling all over the place. Here we either had a 1 or a 0. I'm going to get this going again. I got this thing to stop by changing the baud rate. Let's go back to the default and get it started again. Do one more snap. There we go. So if it's picking up all those little ones. Alright, that's the signal we're going to use to control this LED. When it goes to high, we're going to tell the Arduino to set this LED to turn it on. Okay, so we're going to wire this in. Got to make sure we think about polarity. Got my long leg on here, and I'm going to have it be towards this side of my breadboard, not this side. So let's go ahead and press that in over here. Doesn't really matter where I press it in. This side had the long leg, this side was a short leg. I need a couple wires. So I got a green one and another red one. These are super long. Well, we'll just go with them. I don't know how long these are. It's probably the longest ones I've got. We're going to take this one, go from the long leg, and this is the positive side. This is going to be, we're going to send stuff out from the Arduino into the LED. So I'm going to use pin 3. I'll push it in here, then I'll turn it so you can see. I'm just using pin 3. So we're going to send stuff out of here, going through our wire. It's going to go into the positive side of our LED. The other one, we're going to use green for this one. You can use whatever color you want. And we're going to set this one to ground. And on mine, I've got a ground over here. So I can pick one of these. We'll pick that one. Okay, that looks pretty good. Some Arduinos don't have lots of grounds on them. We would have to use our little rails right here. Set one to ground, set the other one to 5 volts. But we've got plenty on this one. Alright, so we're going to take the information from here, 0 to 1, have our code, take a look at it, and then we're going to say, hey, if it's a 1, I want you to turn this thing on. Okay, so let's go ahead and do that. Close that down, make this bigger. You've already collected the information. We're taking a look at it, and now we need to say, if it's a 1, do this, turn the LED on. So if the sound sensor equals, notice I'm using 2 equal signs and not 1. 2 equal signs means I'm going to check to see if it's this value. 1 equal sign says I'm assigning it this equal value. So 2 equal value, 2 is necessary for right here. So sound sensor, check to see if it is a 1. And whoop, we need the curly brackets here. So what do we want it to do? We want it to digital write. So we're going to send a digital signal. We're going to write a digital signal, 0 or 1, and we're going to send it out of pin 3. And we're going to have it do what? We're going to have it be high. We're going to have it be a 1, which will be 5 volts for us. And it'll semicolon to end our sentence. Okay, so that turns it on. Now, if I just leave it like this, actually, before I go to that, let's go back up to pin mode here. We're going to unmessage that. And anything, maybe I'll talk about that just for a second. When I ever do this, I can put messages over here, and it'll be messages to myself, to other programmers. We'll see these, and it won't affect our program. I just did that to knock that out for a minute, because I didn't need it right at the moment. Now we do need it, because pin 3 is headed over to the LED, and we've got to make that an output. So output for pin 3. Now it knows not to be an input, but it's going to send information out of this pin to the LED. Now if I leave it just like this, what's going to happen, as you might imagine, is once we make a noise that the sensor picks up, it's going to send a 1 or a high into the Arduino. Our code says take a look at that and then turn it on, and then we have nothing after that, so it's just going to stay on. So let's just give that a try. When I write code, I often like to as I create things, try it out. So if there's a problem, I can more quickly find where the error is. Give it a moment here to upload. Little good luck squeeze here. There we go. Ooh, went on, which doesn't surprise me because I'm talking, and if I go to the monitor, it'll probably be back to 0. All I need is, I snap, it goes on. We don't have anything to turn it back off. That part looks great. And maybe that's all we wanted to do. Maybe it's an alarm. When we hear noise, we turn on the alarm. But I want it to go just on for briefly when it heard something and then go back out. So we're going to change our code up just a little bit. We can do else and say else do, there's a little variety of things we could write it. Let's just try this one, else and then low. So if it is a 1, do this, otherwise make sure that light is low. Send a low, write a digital low to pin 3. I'll turn it back off. Let's give that a try. Now we don't expect the light to stay on like it is. It's going to just kind of flicker. It'll be turned on and then go right back out when the 1 becomes a 0 again. Says it's done. Let's give it a try. Whoop. Okay, we got, that's better. Now it's flickering on and off because my voice is analog. I don't speak it digital, so I'm blowing on it, whistling. It's getting, if you remember that signal from before, that's just fluctuating all over the place. Even though I'm picking up the 0s and 1s, it's going to look like a bunch of, a series of highs and lows, back to back, as I make noise. So you get that flickering effect. Oh, off the cameras a little bit. So we're getting a bunch of 0s and 1s back to back to back as I'm making noise, or at least close enough so it can hear me, and causing the LED to go on and off rapidly. So that's pretty cool. Anyway, that's about all I wanted to do with this. We're taking our sound, we're doing a little code, transforming that energy. We're also getting some energy from our computer and transforming into this light. And the light could represent anything. It could be, we could have a servo over here, it could open up or close the door. The light, just the LED is just a quick, simple idea that we can get a good example of this. Okay, so that is it for this lesson. I will see you on the next video. I got a little error message that's popped up. Okay, welcome. We got another project for you today. Give it a moment here to up. That's better. Now it's flickering. Yeah, fabulous. Fabulous. Yeah, okay.